Hello all, today in this video we are going to see about the topic pericyclic reactions. It is a very important topic, it has a good weightage also, okay. So in organic reaction, pericyclic reactions play a vital role. First of all, what do you mean by pericyclic reaction? From the term itself, it is very clear that peri means sides, okay. Peri means sides. There is a cyclic shift of electrons. There will be a cyclic shift of electrons along the sides. For example, if you have this compound, the shift of electrons will be like this. That will be a cyclic shift of electrons along the sides. Okay, hence it is known as pericyclic reaction. This is a very simple introduction about the pericyclic reaction. Then, this pericyclic reactions can be broadly classified into three types. Okay, electrocyclic reactions, then cycloaddition reactions, then sigmatropic rearrangements. Okay, sigmatropic rearrangements. Electrocyclic reactions, cycloaddition reactions, and then sigmatropic rearrangements. Further, it can be another one division we can add, like Diels-Alder reaction. Okay, Diels-Alder reaction. This Diels-Alder reaction is a vast topic. So we can classify it into four types: electrocyclic, cycloaddition, sigmatropic, and Diels-Alder. So first of all, we are going to see about electrocyclic reaction. And before moving on to the electrocyclic reactions, you must understand some basic terms. Okay, some basic terms like Homo-Lumo, then con rotation, disrotation, then C2 axis of symmetry, plane of symmetry. These and all you must understand before moving on to the topic. Okay, so today in this video we are going to see about Homo-Lumo concept. Okay, Homo-Lumo concept. In CSIR they have asked many questions in calculating the number of nodes and then Homo and Lumo. Okay, so now we are going to see about the Homo-Lumo concept. First of all, what is Homo? It is nothing but highest occupied molecular orbital. Okay, highest occupied molecular orbital. What is Lumo? It is lowest unoccupied molecular orbital. What is occupied and what is unoccupied in the sense, if electron is present, okay, if electron is present, that is known as occupied. If electron is not present, then it is known as unoccupied. What does this highest means? Suppose if I am having two orbitals, here electrons are present and here also present. So the highest occupied orbital, that is the highest orbital in which the electrons are present, is known as HOMO. This is known as HOMO. You shouldn't say this one is HOMO because highest orbital, you have to look for highest orbital. Then what is lowest unoccupied? So lowest unoccupied means that particular orbital shouldn't have electrons. It should not have electrons and it should be the lowest orbital. See, for example, if you have like this and this is a HOMO, both the orbitals doesn't have electrons. They don't have electrons. But you have to see for lowest orbital. Hence, this is LUMO and this is HOMO. Okay, this is the Homo-Lumo concept. You will be clear when I provide examples. Okay. See here, for ethylene, what you have to see is first calculate the number of pi electrons. Calculate the number of pi electrons. Here there is one sigma bond and one pi bond. One pi bond means 2 pi electrons. So here the number of electrons, pi electrons, is 2, right? That's it, very simple. What is this? It is heat. This is light. Okay, electrons will undergo excitation in presence of light. Whenever you see H nu, the electrons will get excited. Okay, will get excited. See, the number of pi electrons is 2. Then draw these. One orbital can occupy 2 electrons, right? One electron can occupy one orbital can occupy 2 electrons. Hence, here it will be like this in thermal condition. In thermal condition, 2 pi electrons here. Then this is the HOMO because the electrons are present here. It is HOMO. Then here the electrons are not present. This is LUMO. Okay, this is the HOMO and this is the LUMO. See here, first of all, the electrons will be present like this. But in presence of light, I have already told you that electrons can undergo excitation. So what happens is this electron moves here. Okay, psi 2, it moves here. So now which is HOMO? Psi 1 is not the HOMO. Psi 2 is the HOMO. Because here the electrons are present. Highest orbital in which the electron present is said to be HOMO. Hence psi 2 has 1 electron. This is why this is HOMO, right? And the lowest unoccupied orbital where the electrons are not present is psi 3. This is the LUMO. Hence, if the question is like this, HOMO of ethylene in thermal condition, HOMO of ethylene in thermal condition means it is psi 1, right? But if they are asking like HOMO of ethylene in photochemical condition, okay, photochemical condition, then it will be psi 2. Similarly, if they are asking for LUMO in presence of thermal condition, then psi 2 will be the LUMO. But if they are asking photochemical condition, then psi 3 will be the LUMO. Okay, if I give you another example, it will be clear. Let me give you another example. 1,3 butadiene. Okay, 1,3 butadiene. Count the number of pi electrons. 1 pi bond, 2 pi bond. So which means 4 pi electrons. Okay, now this is thermal condition and this is photochemical condition. Okay, psi 1, psi 2, psi 3, psi 4. These are nothing but just orbitals. Okay, 4 pi electrons. Each orbital can carry 2 electrons. Hence, you can arrange the 4 electrons like this, right? Now, which is the HOMO in thermal condition? Because in thermal condition, it will not undergo excitation. Just as such, you can give as such. So, psi 2 is the HOMO, right? Highest orbital in which the electron present is HOMO. Psi 2 is HOMO. Here, the lowest orbital, both are unoccupied, but which is the lowest orbital? It is psi 3. Hence, this is the LUMO. Okay, this is the LUMO. In thermal condition, it is like this. But in photochemical condition, this 4 pi electrons, first of all, it will be like this. But you are giving light. So what happens? It will undergo excitation and it will move like this. So now psi 3 is the HOMO, right? Psi 3 is the HOMO and psi 4 is the LUMO. Okay, psi 3 is HOMO and psi 4 is LUMO. This is how you have to calculate HOMO. This is how you have to find out which is the HOMO and which is the LUMO for the given compound. Okay. Now, I will give you a compound, but I am not going to say the answer. You are going to post it in the comment section, okay? Hexatriene, 135 hexatriene. So, for this 135 hexatriene, what is the HOMO in thermal condition and what is the LUMO in photochemical condition? Okay, this is my question. What is HOMO in thermal and what is the LUMO in photochemical condition for this 135 hexatriene? If you know the answer, then please comment in the comment section so that I can check. Okay. So this is how you have to find out which is the HOMO and which is the LUMO for the given compound. Next, we are moving on to the another topic, number of nodes. Number of nodes calculation. It is very simple, okay. Number of nodes calculation is very simple and has been asked in CSIR and GATE also. See, when you will say, you will use the term node between two different charges. If you have plus plus, then there will be no node, okay. There will be no node between these two. They can form a bond. But if you have plus minus, there is no bond formation. Instead, you will have node, okay. What is a node? It is formed between two different charges. Whenever you have two different charges, that is said to be node. And the probability of finding an electron in the node is 0. Okay, the probability of finding an electron in the node is 0. You would have studied this in quantum. So here, whenever they have asked you like number of nodes, suppose number of nodes in, see here, if you have psi 1, then the number of nodes is n minus 1. This is very simple. N minus 1 is the general formula to calculate the number of nodes. If you have psi 1, this 1 is n, okay, n value is 1. 1 minus 1, it is 0. So psi 1 has 0 nodes. Psi 1 has 0 nodes. Similarly, if I am asking for psi 4, what you should do? 4 minus 1, which is 3. So the psi 4 has 3 nodes. That particular orbital has 3 nodes. Okay, psi 4 has 3 nodes. If I am asking for psi 3, then what will you do? 3 minus 1, it has 2 nodes. Okay, this is how you have to calculate. Very simple. Number of nodes, if they are asking, then just use the formula n minus 1. If you want to calculate the number of nodes, just n minus 1 formula. If you are having psi n, then use n minus 1. This is the formula. Okay, but they will not ask you as simple as such. Okay, they will give you the question like number of nodes in HOMO of butadiene. 1,3 butadiene. So first of all, number of nodes, you know that it is n minus 1. But they have given in the HOMO of 1,3 butadiene. First of all, you must know what is the HOMO. So 1,3 butadiene means it will have 4 electrons. Okay. They will also given you the condition. If suppose they are giving you in the thermal condition, then psi 2 will be the HOMO, right? If psi 2 is the HOMO, then you can calculate nodes. Nodes is equal to n minus 1. So 2 minus 1 equal to 1. So for number of nodes in HOMO of 1,3 butadiene, the answer is 1. This is how you have to calculate. Okay. One more thing. In ethylene, how you will draw? Like this, plus plus, minus minus. This is our psi 1. Here there is no node, 0 nodes. See here, between two same charges, so there will be no node. Okay, this is psi 1, this is 0. But if I am drawing like this, psi 2, here there is a node, right? Because it is formed between plus and minus. Between two different charges, there will be a node. Hence, here one node is present. Okay, this is how we are calculating the nodes. Between two same charges, there will be a bond formation and there will be no node. But between two different charges, there will be a node present. Okay. Now you know how to know which is HOMO and LUMO, and also how to calculate the nodes. Okay. Now we are going to draw the molecular orbital. Like, see here, this ethylene, this number of carbon atoms is 2, right? So you can draw two types of orbital diagram. See here, it is plus, plus, minus, minus, and plus, minus. Here it is plus, minus, and minus, plus. Okay. This is how you can draw for ethylene. Psi 1, psi 2. See, I have already told you that for calculating number of nodes, it is n minus 1 formula. Here 1 minus 1, it is 0 nodes, and here 2 minus 1, which is 1 node. You can account for this. Okay, the formula, this is the formula, but you can account from this diagram. See here, it is plus and plus. I told you whenever you have same charges, there will be no node, right? Hence here there is no node. But see here, it is between plus and minus. It is between opposite charges. So definitely there will be a node. Hence here there is one node, here there is no node. This is how you are going to calculate, and this formula is n minus 1, but from the diagram itself you can calculate. Okay. See, similarly for 1,3 butadiene, you have 4 carbon atoms, then 4 different orbitals you can draw. Orbital diagram. This is one. I think I have to draw smaller. 1, 2, 3 and 4. Okay. You can draw 4 different patterns. Okay. Now this is psi 1, this is psi 2, this is psi 3 and this is psi 4. How to calculate number of nodes? Here it is 0 nodes, here 1 node, 2 node and 3 nodes, right? Now this is a nodes you have find out. Here you should have that nodes. See, here you should not have any node. So same charges should be present so that there will be no node. Here in psi 2 there should be one node. So you have to draw like there should be one node. For example, plus plus, minus minus. See, this two, between these two charges there will be no node because they are same charges. But between these different charges there will be a node. So one node is present. So I can draw like this. Then see, for psi 3 it is 2 nodes. So how will you draw 2 nodes? You just try, make a try. Plus, then here minus. So here there is a node. You have to draw 2 nodes. So here minus, here plus, right? So there is 2 nodes. There will be 2 nodes. Then here 3 nodes. It is very simple. Plus minus, plus minus. 3 nodes. See, this is how you have to draw. Okay. First, see the number of carbon atoms and draw as many structures, and you know that for psi 1 it is 0 node, for psi 2 it should have 1 node, and for psi 3 it should have 2 nodes, and for psi 4 it should have 3 nodes. So like that you have to draw. Okay. And there is a trick. Okay. There is a trick for drawing this. See, if psi is odd, then terminal signs are same. But if psi is even, it should have different signs. It may be look little confusing, but see here, if suppose psi 3, okay, psi 3 is odd or even, 3 is odd or even, it is odd. So the terminal in the sense end, okay, the end p orbital, the terminal p orbital should have same sign. Okay, it should have same sign. If this is plus, this should also be plus. Okay. This is how you have to draw. So if you draw like this, then psi 3 2 nodes. You should have 2 nodes. So where will you have 2 nodes? Here minus and here minus. This is how you have to draw. Psi odd should possess plane of symmetry and psi even should possess C2 axis of symmetry. These are the tricks. If you follow the trick, you can easily draw the diagram. Okay. In this video, we have seen how to find out which is HOMO, which is LUMO, and how to calculate the number of nodes, and also how to draw the diagrams. These and all we have seen. Okay. Stay tuned. Thank you so much for watching.